Hi, students and friends. This is your host and teacher Sayyid Ayazuddin Haider, and you're watching Learn and Teach by Sir Ayaz. I will continue my video session for past papers, and this time I have selected 5070 paper 41, and it's of October November 2023. It's alternative to practical. The total time is 1 hour. You have to answer all the questions. You are allowed to use calculator. The total mark for this paper is 40. Notes for use in qualitative analysis are provided in the question paper. It will be like this. These are the notes for use in qualitative analysis. We have the test for anions, test for aqueous cations, test for gases, and flame test for metal ions. So let's continue with the paper. Here's question number 1. Student investigates the rate of reaction between calcium carbonate and dilute hydrochloric acid. Figure 1.1 shows part of the apparatus the student uses. The student determines the rate of reaction by measuring the volume of carbon dioxide produced in a fixed time. So here's figure 1.1 with apparatus X, delivery tube, dilute hydrochloric acid, and calcium carbonate. Part A, name apparatus X. Now this apparatus is known as conical flask. So you'll write conical flask here. Part B, the student has incorrectly positioned the delivery tube in the apparatus shown in figure 1.1. Complete figure 1.2 to show the correct position of the delivery tube. The rest of the apparatus the student uses to collect and measure the volume of gas produced. So here's figure 1.2. Apparatus X is shown here with dilute hydrochloric acid and calcium carbonate. They're asking us to draw delivery tube in the correct position. So delivery tube must be it should not be dipped in the solution as gas is produced. And you need to collect the gas. We need to draw the gas syringe to collect the gas. So here you have delivery tube, sorry, gas syringe to collect the gas, plunger, and label the diagram. This one is gas syringe, and this one is delivery tube. Moving to next part. Part C, the student collects 48 centimeter cube of carbon dioxide during the first 2 minutes. Calculate the mean rate of reaction in centimeter cube per second during the first 2 minutes. Now we need to convert these minutes into seconds. You know that in 1 minute, there will be 60 seconds. Therefore, 2 minutes, x seconds. So x is equal to 60 multiplied by 2. What you will get? You will get 120. 120 seconds. So 48 centimeter cube of carbon dioxide collected in 120 seconds. So the rate must be 48 divided by 120. So the answer must be 0.4 centimeter cube per second. Moving to next part of this question. Moving to next question, hydrochloric acid, HCl, is neutralized when it is added to aqueous potassium hydroxide, KOH. Here's the reaction equation. KOH plus HCl gives KCl plus H2O. The reaction is exothermic. P is aqueous potassium hydroxide. Q is 2.24 mole per dm cube hydrochloric acid. The student determines the concentration of potassium hydroxide in P. Student does 6 experiments. In step number 1, student uses a volumetric pipette to add 25 centimeter cube of P to a plastic cup. Step number 2, uses a measuring cylinder to add 20 centimeter cube of distilled water to the plastic cup. Step number 3, stirs the mixture in the cup with the thermometer and records the temperature to the nearest 0.5 degrees centigrade. Step number 4, uses a burette to add 5 centimeter cube of Q to the plastic cup and stirs. You're noticing one thing, the stirring is happening. The stirring is happening is in order to have an equal distribution of heat in the mixture. Step number 5, records the highest temperature reached. Step number 6, empties the plastic cup and rinses it with water. Step number 7, repeats steps 1 to 6 using 5 different volumes of distilled water and Q so that the total volume in the cup is always 50 centimeter cube. The students' results are in table 2.1. So here's table 2.1. A. Complete table 2.1 by filling in the 3 missing values. Now every time we are having total volume of 50 centimeter cube. They have mentioned the total volume of the liquid should be 50. It's mentioned here. So in number 2, 25 plus 10 gives 35. So we have to write 15 in order to make it 50. In experiment number 4, 25 plus 7, we get 32. So you have to add 18 centimeter cube of Q to make it 50. The temperature rise for experiment number 6, 33 minus 26.5. 33 minus 26.5. 6.5. So these are the values. Moving to next part, parts of the thermometer used in experiment 5 are shown in figure 2.1. The liquid levels inside the thermometer are missing. Complete figure 2.1 by drawing in the liquid level to show the initial temperature of P in experiment 5, the highest temperature reached in experiment 5. Initial and final temperature, initial or the highest temperature experiment number 5. Here's experiment number 5. It's 26 and 32.5. 26 centigrade and 32.5 degrees centigrade. So 26 so 32.5 must be here between 32 and 33. Draw a graph of temperature rise against volume of Q on the grid in figure 2.2. You should plot the point 00 as there is no temperature rise when no Q is added. Plot the temperature rises and volumes of Q from table 2.1. Draw straight line of best fit for the first 4 points. Draw straight line of best fit for the last 3 points. Extend the line so that they intersect. So here's the graph. So we need values. These are the values. So for the temperature, we have 2, 4, 6, and 6.5. 2, 4, 6, and 6.5. There are 6 experiments. 2, 4, 6, 6.5. Two, 4, 6. Now they're doing 6.5. It must be between 6 and 7. What about the volume of Q? Volume of Q. Here we have volume of Q. 5, 10, 15, 18, 20, 25. Five, 10, 15, 18, 20, 25. These are the volumes of Q. So 5, it must be here. 10, 15. What about 18? 16, 17, 18. Here we are having 18. We have 20 and 25. So for 5 centimeter cube, the temperature rise is 2. So I will put cross here. For 10, the temperature rise 4 degrees centigrade. At the cross 15, we have 6. And after 15, that is from 18. The temperature rise is 6.5. And after that, we have 6.5 for 20 also, as well as 25. Now join these lines. Join these three, last three. Let's see the intersection. This intersection. This will be the final graph. Part D, the point where the two lines intersect indicates the volume of Q that exactly neutralizes 25 centimeter cube of P. Determine the volume of Q where the two lines on the graph intersect. Let's see the line. It must be between 15 and 18. So it's like 16.5. 16.5. So I will write 16.5 centimeter cube. EQ is 2.24 mole per dm cube hydrochloric acid. Use your answer to D to calculate the concentration of potassium hydroxide in P. Now for hydrochloric acid, first of all, we'll calculate the moles of hydrochloric acid in the volume we have calculated. So I will write HCl in 1000 centimeter cube. As you know, 1 dm cube is equal to 1000 centimeter cube. 1000 centimeter cube contains 2.24 moles. Therefore, 16.5 centimeter cube contains X moles. Do the cross, what you'll get? X is equal to 2.24 multiplied by 16.5 divided by 1000. 2.24 multiplied by 16.5 divided by 1000. These are the moles of HCl, 0.0369. 0.0369. Two significant figures are given after point. So we have 0.0369 moles of hydrochloric acid. Look at the ratio of combining ratio of KOH and HCl. It's 1:1, which means the moles for KOH is also 0.0369. Now the volume of KOH, how much volume of KOH is used? It's 25 centimeter cube. P is KOH. So you write 25 centimeter cube contains 0.0369 moles. Therefore, 1000 centimeter cube contains X moles. So it will be 1000 multiplied by 0.0369 divided by 25. 1,000 multiplied by 0.0369 divided by 25. 1.476. 1.476 mole per dm cube of QH. Okay, moving to next part. Part F. A measuring cylinder is used to measure the volumes of water. Suggest why the volumes of water in table 2.1 are not given to 1 decimal place. Now, the reason is that the precision of measuring cylinder is insufficient. It's not sufficient. Precision of measuring cylinder is not sufficient. Part G. State and explain why a plastic cup rather than a metal cup is used in these experiments. So definitely the reason is that plastic is a better insulator than metals. Or you can write a reverse argument like metals are good conductor than plastic. Plastics is a better insulator of heat than metal. ORA means or reverse argument. You can even write less energy transferred from solution to surrounding. You need to avoid the loss of energy to the surrounding. Is from solution to surroundings. Part H. State why the mixture is stirred before measuring the temperature in these experiments. Definitely, we are looking for even distribution of heat or temperature same throughout the liquid. Moving to next question, which is question number 3. A student investigates solution X and solution Y. Both solutions are colorless. A. The student does some test on X. Table 3.1 shows the notes the student makes about these tests. Table 3.1. Test on solution X, then observations for these tests. Like first test, add 1 drop of aqueous sodium hydroxide to X in a test tube. Observation, white precipitate which then dissolves. 2. Add aqueous sodium hydroxide to X in a boiling tube, warm the mixture and test the gas produced with damp litmus paper. Observations, pungent smell of ammonia, no change to the litmus paper. 3. Add aqueous dilute nitric acid and aqueous barium nitrate to solution X in a test tube. Observation, white precipitate. Part of the method for test 1 is missing. Describe the missing part of the method that is needed to give the observations shown. You have to write excess aqueous sodium hydroxide was added. Excess aqueous sodium hydroxide was added. sodium hydroxide was added. This is a test for the cation. So you can see here also excess. Everywhere it's written excess sodium hydroxide. So you have to write excess sodium hydroxide here. Okay, number 2, the observations for test 1 are incomplete. State one other observation which is made for test 1. Now it must be colorless solution. Colorless solution obtained. Three, suggest why the ammonia produced in test 2 has no effect on the litmus paper. Now they have mentioned the pungent smell gas and it's ammonia. They have also mentioned ammonia, but they are also saying no change to the litmus paper. If you look at the test for ammonia, the test for the gases, it's ammonia. It's tested by turning damp red litmus paper blue. So litmus paper must be blue in color. That's why there is no effect on the litmus paper. So you can write blue litmus paper was used. Blue litmus paper was used. Number 4, solution X contains 2 cations. Identify the cation in solution X which produces ammonia in test 2. So if you look at the test here, it's only one ion which produces ammonia on warming with sodium hydroxide, and it is ammonium, that is NH4 positive. So you write ammonium. They ask identify the cation which produces ammonia, so you write ammonium here. Number 5, explain why the solution a student cannot identify the second cation in solution X from the test and observations in table 3.1. So if you look at the observation with aqueous sodium hydroxide, they are saying white precipitate which then dissolves. So if you look at the test for the cations with sodium hydroxide, you will find that there are 2 ions, Al3 plus and Zn2 plus. They have same observation. They have same observation. White precipitate soluble in excess giving a colorless solution. As well as for Al3 plus, white precipitate soluble in excess given a colorless solution. So you can write more than one cation produces the same result. You can even mention the name of these cations. That the cations may be aluminum or zinc. Cations may be aluminum or zinc. We are not sure from these results. Identify the anion in X. Now anion in X, they have added barium nitrate, acidified barium nitrate and white precipitate obtained. A test for anions. Here we have test for anions. If you look at the test for anions, it's sulfate. It's giving white precipitate with acidified barium nitrate. So you'll straight away write sulfate. B1. The student adds universal indicator to solution Y in a test tube. The universal indicator turns red. Identify the cation present in Y. So universal indicator is turning red. So you have to identify the cation present in Y. Where is Y? Solution Y. So if it is turning red, it must be H positive ion. This is responsible, acidic ion, responsible for turning the universal indicator to red. You can even write hydrogen instead of H positive. Number two, student adds a piece of magnesium ribbon to Y. Hydrogen is produced. Suggest two observations the student makes. So you can write any two from these. Like gas is produced, so you can write effervescence or bubbling. Effervescence or bubbling. And it's reacted with magnesium, so you can write solid disappears. Solid magnesium disappears. You can even write solution gets warmer. Solution gets warmer. This reaction, solution gets warm. It's an exothermic reaction. And then you will also get colorless solution. If you want, you can write this also. Solution remains colorless. Number three, describe how the student test the gas to show that it is hydrogen. It's very easy. Burning splint. Can bring burning splint. Burning splint. If you don't remember the test, you can see it from here. These are here. Test for the gases are provided here. See hydrogen gas, burning splint pops with the lighted splint. With the lighted or burning splint. Or lighted splint. Pops up or produces squeaky sound. Moving to next part. The student adds dilute nitric acid and then adds aqueous silver nitrate to Y. A white precipitate is observed. Number one, identify the anion present in Y. No, test for the anions. If you look at the test for the anions, it must be chloride. You see, acidify with dilute nitric acid, then add aqueous silver nitrate, must be giving white precipitate. So it must be chloride. So you write Cl minus or chloride. Now what they are saying, identify Y. Now you have the anion here and you have the cation here. We have, this is anion, there is a cation, here is a cation. So it must be hydrochloric acid, HCl. Number four, ammonium sulfate is a salt used in fertilizers. Ammonium sulfate is prepared by neutralizing dilute sulfuric acid with aqueous ammonia. Plan an experiment to prepare pure dry crystals of ammonium sulfate. Your plan should include the use of common laboratory apparatus, dilute sulfuric acid, aqueous ammonia, methyl orange indicator. No other chemicals should be used. Your plan should include the apparatus needed, the method to use. You may draw a diagram to help answer the question. First of all, I will write the details. Now they are saying you have to mention the apparatus. So in this, you're definitely using a burette or volumetric flask. Straight away you can write, use a burette or volumetric flask. First of all, you can write any six of these. Any six. Any six from. Use a burette or volumetric pipette. Then add known volume of ammonia or sulfuric acid in a flask. Add a known volume of ammonia or sulfuric acid in a flask. With indicator. If you want, you can write the name of the indicator. Add the other reagent into a flask. Now you have already mentioned the name of ammonia and sulfuric acid, so no need to write their name again. You can write add the other reagent. You can write add the other reagent. Add the other reagent in a flask. Until color change or until end point. Until end point. If you have used specific indicator, you can mention the change in color. Like if you have used methyl orange, you have to mention, but then you have to name the reagent also. Repeat using the same volume but without indicator. Repeat the experiment using the same volume without indicator. Now next step must be heating or evaporation. Evaporate through gentle heating. And write crystallize. And in the end, dry the crystals. Now in the question, they are saying, you may draw a diagram to help answer the question. Now, what diagrams you can draw for this question? They provided you with the space. You can draw burette or pipette. Burette or pipette. Like burette. Should be like this. Some labels. Name it. You have to write burette, pipette. It must be above. You write the name, pipette. Titration flask is also used in this experiment. So draw titration flask. This is conical or titration flask. So you can draw these glasswares for this planning experiment. That's all for this video. Thanks for watching. Press like and share my videos. For more videos, subscribe to my channel. Press the bell icon.